Welcome to Multimodal Insights, using voice and gaze detection to unlock the power of sales data. Multimodal. In the high-pressure world of sales, when a team's numbers start slipping, all eyes turn to the sales manager. Upper-level management is dissatisfied, and a solution is urgently needed. Enter Multimodal Insights, a powerful web application designed to address this challenge head-on. With its natural voice and gaze interactions, Multimodal Insights provides a streamlined interface for analyzing team performance. Through granular queries and intelligent insights, the sales manager gains the tools to make informed decisions and drive success. To access our tool, simply visit our secure website at multimodalinsights.com. Once inside, we can navigate to the instructions page. With Multimodal Insights, we can make granular queries by selecting a specific set of people, data field, and optionally a date range. By default, the date range encompasses all of time, providing a comprehensive analysis. Need to know who performed best or worst during a particular period? Just ask the system, and it will analyze the data for us. The result will be printed to a terminal and also dictated to us for a seamless experience. Before we get started, we need to configure the gaze tracker. Click the Train Gaze Tracker button, which will take us to a dedicated page for target practice. Here, we train the gaze tracker by looking at the targets on the screen and clicking them. Each time we do this, we provide the tracker with a valuable training example. Make sure your face is within the red square over the video feed. To properly configure the gaze tracker, we usually need to click the targets about 10 times. As we do this, we'll notice the red dot in the screen begins to follow our gaze. That's when we'll know the tracker is ready. For optimal results, we can continue training if desired. The training data is saved within a browser session on your local machine. If, at any point, we wish to reset the calibration, we can simply revisit the instructions page and start over. This will clear the calibrations and redirect you to the calibrations page. It's important to note that the gaze tracker solution is fully written in JavaScript and executed on your local machine. Your video feed is not being sent to any third party for analysis, so you can feel comfortable interacting with our system and only our system. We've noticed that the gaze tracker can be sensitive to different cameras, lighting conditions, and face positions. That's why we've streamlined the adjustment experience for you. Now that the gaze tracker is configured, we're ready to dive into the tool. Clicking Launch in the top navigation bar will take us there. We have two datasets available for exploration. While future versions will incorporate data from additional sources, for now, we have two example datasets at your disposal. For our demonstration purposes, let's begin with dataset 1. However, don't hesitate to visit our site and explore dataset 2 as well. The choice is yours. Jessica.
Please select a data field.
Revenue.
318,905.
April 7th to April 13th.
10,369.
Add John.
12,929.
Add John.
26,957.
Remove John.
14,028.
Win rate.
0.7.
Who has the best performance?
Josie has done the best, leading in revenue completed sales win rate.
Who has done the worst?
John has done the worst, trailing in revenue completed sales customer conversations.
Who had the worst performance from February 11th to February 17th?
Jessica has done the worst, trailing in revenue completed sales win rate.
What about customer conversations?
157.
The system utilizes the JavaScript Web Speech API and GazeFilter.js to process inputs. I chose to deploy the system on a web server with Django and Docker to make user testing easy. When a user clicks, the system starts recording and listens for spoken words using the Web Speech API. Simultaneously, the GazeFilter.js module tracks the user's eye gaze position. We tried 3 gaze detectors and found this works best because of its easy training process. When a word is detected, the application logic combines the speech and gaze data to disambiguate the user's voice input and update some parameters. These include the set of names heard, dates heard, query fields, and special keywords. After an activity, the system triggers actions based on the updated parameters, involving identifying the best and worst performers or executing specific queries. To test the system, we presented test subjects with the challenge to randomly select one of the duplicate Johns that requires gaze disambiguation. Test subjects used their own machines and were given limited background knowledge. Out of 4 subjects, the average success rate was 75%. We noticed users got better as they used the system. Me and subject 2 used the system for longest and reported 83% average success. We noticed issues on non-Chrome browsers and unexpectedly found the system spoke Spanish on Macs, which has now been resolved. We conclude by noting solid usability scores which are impressively consistent across different operating systems and hardware, indicating the core tools and processes are working well. Future improvement includes more integration of gaze disambiguation, more robust system-generated insights, and integration to real data sources.